everyone. Today we're starting looking at factoring by two terms. So hopefully you came to this website. It did require you to create an account, but you just have to sign in through Google, and that's all you need to do. And completed this. So moving these blocks like it instructed you to do, and then answering those 5 questions that it had after that. So we're just going to run through that really quick. That way y'all can see if you did it right, if you got the answers right. And then I'll give some explanation behind what we're actually looking at. So what this title says at the top right here is talking about the sum and difference of cubes. And they're describing that with stacking blocks pretty much virtually. So you see that we have a giant cube right here and then a tiny cube right here. So kind of what we're going to be looking at is maybe finding the sum or the difference of those cubes. And we'll talk a little more about how we actually do that once we get there. So right here it instructs us to drag the green and purple blocks on top of the pink cube to create a bigger block. So it should be like this. And then drag this one. Make it all match up a little bit. Okay, and then the second bullet point says, by calculating the volumes of the green and purple blocks, which we just dragged up there, it wanted you to find the total volume of the pink and yellow cubes. So this is kind of what we're going to be doing. We're going to be finding the sum of those cubes, pretty much the pink and yellow ones, by using these two that we just dragged up there. So let's kind of go in deeper and see how we do that. So you should click this challenge me button. All right, so then the first question it asks is, what is the volume of the purple block? So you may have to think back a little bit about how do we even find volume. Remember, it's length times width times height. So let's look at these little measurements it gives us. Let's see, it says this distance right here is A minus B. So we know that's going to be one part of it. I would consider that the length right here. So the length is A minus B. Okay, now let's look at the width right here and the height. So the width is going to be just like this yellow block back here because that is a square shape. So that measurement right there is B, and then the height's going to be the same thing, B also. So let's look at our answer choices. Which one has B twice and then also A minus B? And that's going to be C right here. So theoretically, if we had numbers to go in those variables, that would give us our actual volume. But since we don't, we're just multiplying those variables together. So B times B times A minus B is our volume for the purple block. Okay. All right. So then it's saying, putting these numbers in for A and B, what is the actual volume, like we talked about? So our equation was B times A minus B. So let's plug in 6 and 2 into that. So if we're going to plug in 6 and 2, let's see, we had B times A minus B. We're plugging in 6 for A and 2 for B. So that is 2 times 6 minus 2. Okay, let's do that 6 minus 2 first. So that's 4. So then we have 2 times 4. Okay, now we just need to multiply all that together. So 2 times 2 is 4, and then 4 times 4 is 16. So that is going to be our volume for the purple block, 16. So let's type that in, see if we got it. There we go. All right, so now for this little not even a paragraph, a sentence, I guess. It wants you to highlight the words that are in the parentheses, so of these colors, pink, yellow, purple, green, to make this statement true. So it says that the volume equivalent to A cubed plus B cubed, so it doesn't tell us what that is, but just the volume that's equivalent to that, can be found by subtracting which blocks from the prism with volume a squared times a plus b. So let's think about what prism is it talking about that has a volume of a squared times a plus b. So a plus b is this long part right here, okay, all the way from the bottom of the pink cube to the top of the yellow cube. That's a plus b. Okay, so, and then the a squared would be this part right here, and then this front part of the pink cube. So I want you to think about what all does that include? Is that all 4 of the blocks? Is it just the yellow and the pink? Okay, so think about that for a second. Okay, so it's asking us, what can we subtract from whatever you thought that prism was to get a cubed plus b cubed? Okay, and that is going to be the purple and the green blocks. Okay, and we'll go deeper into that on this next part. Okay, so we're subtracting essentially those purple and green blocks from that a squared times a plus b. Okay, so all we're trying to find or write is the equation that's supposed to equal a cubed plus b cubed. So we said that was the a squared times a plus b. So that's either going to be option A or option C. Okay, so that prism minus the volumes of our green and purple. So we're going to choose between option A or C. Now let's look at what our volume of the purple one is. We have to think about that again. So I think we got B times A minus B. So where do we see? I do not see that one in option A. It is in option C though. Let's check the volume of the green block. So for the green one, the width or the length looks like to be A right here. And then the height would be B. So that's already A times B. Okay, then think about what would this front part be? So that would be this whole thing, which is A minus B, right? Because it takes off that little section right there. So we said A times B times A minus B, and that does match the last part on C. So our whole equation, right, is going to be option C. Okay. All right, and then it just asks you this open-ended question: is it possible that the green and purple blocks will ever have the same volume? So I just want you to think about that, keep that in your mind. And I think either of these, it didn't ask you to do anything, whichever option you clicked, but I hope that you thought about that. It's just a little thoughtful question to think about with this situation. So let's start to think about what sum and difference of cubes actually means. So basically, we're either adding together cubes or we are subtracting cubes from each other, right? To find whatever it is that we're trying to find. So in this case, we were trying to find a cubed, which was this pink block, plus b cubed, which was this yellow block up here. So we were trying to find their volumes together, and we were using these additional blocks to find that, right? So we were using this whole volume of all 4 of them minus the green and purple, and that should give us a cubed plus b cubed. And it would be the same thing with difference, right? We're just trying to find the difference, which is a subtraction. Or I want you to think about what would the difference of squares be? So instead of difference of cubes, we're talking about squares. So it wouldn't be a cubed minus b cubed, it would be a squared minus b squared. And we wouldn't be dealing with cubes, we would just be dealing with squares, which are flat 2D, right? So that's kind of the logical differences between those things. Now we're going to actually go into how we factor using these different methods on 2 terms. Okay, so look at this sheet. This was attached on the Schoology page. It's called Factoring with 2 Terms. Okay, and we're going to start looking at these different methods that we were just talking about. So we just have a reminder here at the very top. Remember, the first thing we always have to do for factoring is check for a greatest common factor, and take that out if there is one. Okay, so on all of these, we're going to check for that first and then move on to whichever method we're using. Okay, so these are all for two-term polynomials. So you'll see that this has two terms, all the way down on all of these. This is for two terms. Okay, so let's look at the first one. First, we're dealing with difference of squares. Okay, so again, squares being a 2D shape, this is going to be a squared minus b squared, because difference is subtraction and squares means we're squaring the variable. Okay, so it gives you kind of like a, right here, that front part that is a squared minus b squared, that is going to essentially match the polynomial that it gives us. And then this last part, which in our little model is a plus b times a minus b, is going to be our factors that we end up with. Okay, so first let's look for a greatest common factor, because that's the first thing we always need to do. Okay, so on this first one, we have 9x squared minus 64y squared. Okay, so looks like we can't take out a variable in the greatest common factor because one term has only x's and the other one has only y's. So we're just going to be looking at the number. Okay, so on the first term we have 9, the second one we have negative 64. What do you think could come out of both of those? Okay, so let's think about, could we take 9 out of 64? So actually let me zoom in really quick so we can see a little better. So can we take 9 out of 64 evenly? I don't think we can, right? So what about, what else could go into 9? 3? So could we take 3 out of 64? So let's see, 3 out of 64. Would that go in evenly? Maybe not. Okay, so what do we think would go in there? Is there a greatest common factor? So let's go ahead and try to write our factors if we don't think there is one, okay? So we have our model right here. Okay, so we have 9x squared minus 64y squared. Okay, we're going to try to get that to be just a x and just a y, which means we have to take the square root of each of those terms, right? So taking the square root of 9x squared, that's just going to give us 3x. Okay, so for our first term, that is 3x, and then take the square root of 64y squared, it's going to be 8y, sorry. So plus 8y. Okay, and then that's our plus terms. We need to do the same thing. So we're going to have those same terms, just the difference of those terms. So 3x minus 8y. Okay, so those are our factors for that. So if you don't see any greatest common factors, okay, just go ahead and move on to write your factors. So sometimes there's not going to be one, but you always want to make sure on every problem. Okay, so try the next example by yourself. That's 20x squared minus 45. So try that one by yourself using the same model from up here. Okay, same thing, check for a greatest common factor first and find the factors, and then we will check it together. All right, so let's check this one together. All right, so let's think about, is there any greatest common factor? What? We only have an x on one of these. So let's think about numbers. What number could go into both 20 and 45? The greatest number, what do y'all think? So I think maybe 5. So we could divide 20 by 5, that would give us 4. And then divide 45 by 5, that would give us 9, right? So I think that is our greatest common factor So that's going to be 5. All right. So we're going to write that first, just like we did yesterday. We have that 5 in front. Okay, then we're going to write our 2 factors since this is difference of squares. So this one's going to have the plus and this one's going to have the minus. So we need to take after we've taken that 5 out, it's 4x squared minus 9. So now we're going to take the square root of both of those terms. So square root of 4x squared, that's just going to give us 2x. Okay, and then the square root of 9 is 3. Okay, and then that second term is just going to be the same thing. So 2x and 3. All right, so those are our factors, and we have the greatest common factor listed in the front to show that we took that out before we factored it. Okay, so let's go ahead and move on to our next one now. So this next one is difference of cubes. So now we're moving on to talking about cubes, which is what we were doing on the online problem we just looked at. So you'll see that the difference is this is a cubed minus b cubed. So not talking about squared, but cubed, okay? So this one looks kind of different, right? We have a binomial first, and then after that for the factors, we have a trinomial, okay? But again, this is the model that we're going to follow, okay? So look at this first example, pretty simple, x cubed minus y cubed. So let's check, are there any greatest common factor we can take out? So I don't think so, because we have x's in the first one and then y's in the second one only, and there is only a coefficient of 1 on both of those, so there's nothing that we can take out that's significant. So let's go ahead and find our factors for this. So I'm going to write it right here on the side for the factors. Okay, so we're going to follow that model. So first we're going to have a binomial and then a trinomial. In that binomial, it'll be the difference, and then in this one we'll have a 2 plus signs to follow. Okay, so that first one, we're just taking the cube root, not the square root, right? Since those are since those are cubed, we're going to take the cube root of those 2 terms. So cubed root of x cubed and cubed root of y cubed. So that just gets us straight up x and y. So those are the terms that are going to go right there. Okay. And then all we have to do is first we're going to list the squared version of that first variable. So instead of x cubed, it's going to be x squared. And then in the middle, we're going to multiply those 2 terms together whenever we cube root them. So we had x and y. So it's just going to be x times y in the middle. And then that last one is going to be the second term squared. So y squared. Okay. So that are the factors for that. I have a binomial and a trinomial. That one's pretty easy. We didn't deal with any numbers. Okay. So what I want y'all to do now is try the next example on here for difference of cubes. So let me scroll down. Okay. So we have some coefficients in there now. So it might be a little more tricky, but go ahead and try it. First check for a greatest common factor, remember, and then find those factors using the model for difference of cubes, and then we'll check it together. All right, so for this one first, we probably are going to have a greatest common factor, right? So let's see what we got. So I don't think we're going to have any variables that we can take out, but let's look at the coefficients. So what is the greatest thing we could take out? I think 8 does go into 64, right? So we could take an 8 out. Oops. Take an 8 out, and we'd be left with 64 divided by 8 is just 8. And then a cubed minus, and then 8 divided by 8 is 1. So we don't have to write that 1, but we would be left with y cubed. That's what we'd be left with if we took out that greatest common factor of 8. Okay, so now we're going to follow that model we had before and write our factors. So remember, first we're going to have that 8, our greatest common factor. Then we're going to have a binomial where they subtract, not add, sorry. And then we're going to have the trinomial with all terms adding up. Okay, so first we're going to take the cubed root of that first term. So cube root of 8a cubed. So we know that if we take the cube root of a cubed, that's just a, right? But what about 8? So think about what number could we multiply 3 times to get 8? We're going to multiply 2 3 times to get 8, because 2 times 2 is 4, and then 4 times 2 is 8. So that would be the cubed root of 8. Okay, so that first term is going to be 2a. Okay, and then our last term is just y cubed. So take the cube root of that, that's just y. Okay, and then remember this first term right here is going to be our first term that we had, which was 2a on the left over here, squared. So 2a squared would become 4a squared. Okay, now we're going to take our two terms we got in the binomial and multiply them together. So 2a times y, so we can just write 2ay. Okay, then our last term is the second term of the binomial squared, so that would just be y squared. Okay. All right, now we're going to move on to the last one. So this was difference of cubes. Now we're moving on to sum of cubes. So it looks pretty much the same. The signs are just different. So obviously instead of a cubed minus b cubed, we have a cubed plus b cubed. Okay, and then these signs are a little different in our factors as well. So in that first binomial, we have a plus instead of a minus. And then in the trinomial, we have a minus, then a plus. Okay, so let's look at the first example. Do we see any greatest common factors? I don't see any variables, but I think we could take 2 out of 16, right? So if our greatest common factor is 2, then we could take that out of 16 and we'd be left with 8m cubed plus p cubed. Okay. All right, so now let's look at our factors for this. So we have 2 as our greatest common factor. This first one, binomial is going to add. This next one, we're going to have a minus and then a plus. Okay, so let's look at taking the cubed root of our two terms. So cubed root of 8m cubed. And on the last one we discovered the cube root of 8 is 2. So that is going to end up being 2 and then just a single m. Okay, now what about the cube root of p cubed? That's just p. So those are our two terms in our binomial. Okay, and then for this first one, it's the same thing. We're squaring that first term in the binomial. So 2m squared is going to be 4m squared. Okay, and then for that middle term, it's the two terms multiplied. So 2m times p. Let me rewrite this so it's not that messy. So 2m times p is just 2mp. Okay, and then our last term is the second term in the binomial squared, so that's just going to be p squared. So that is our factors listed. We have our greatest common factor in front. Okay, so now go ahead and try that next example by yourself. A little bit of bigger numbers, but you can always use a calculator to see if that's going to work. All right, so let's look at that one. Let me scroll down a little bit. Okay, we have 343x cubed plus 27. So yeah, it's a pretty big number, right? So let's think about, is there any greatest common factor? So first thing I would probably do is just check if that 27 goes into 343. And I'm going to pull out a calculator right now and just test that really quick. So 343 divided by 27. So no, it doesn't go in evenly, right? But are there any numbers that we could put in that evenly? So think about that really quick. So I can't even think of any numbers off the bat that would come from 27, right? So let's go ahead and just try to factor it and see if it all works out in the end without taking out a greatest common factor. Okay, so we're going to follow that same model as before. So first we're going to have our binomial listed and then our trinomial. And remember, for sum of cubes, we're going to start off with a plus in the binomial and then a minus, then a plus in the trinomial. Okay, so we're going to take the cubed root of both of those terms for the two terms in the binomial. So cubed root of 343x squared. So that x squared is just going to be x, right? Let's see. I'm going to plug it in my calculator and see if I can find the cubed root of 343. So that does have an even cubed root, which works out great, right? Without having that greatest common factor. So the cubed root of 343 is 7. Okay, so that's going to be 7x for the cubed root of that whole term. Okay, then we are looking for the cubed root of 27 now. So let's think about what could we multiply 3 times to get 27. Okay, so what about, we know not 2 because that makes 8, right? What about, let's check 3. So 3 times 3 times 3. 3 times 3 is 9, right? And then 9 times 3 does end up being 27. So that would be our cubed root term. So it's going to be 9. Okay. All right. And then for this part, remember we're taking this first term in the binomial and squaring it. So 7x squared is going to be 49x squared. Okay, next we're taking both of those terms and multiplying them. So 7x times 9. So that's going to be 7 times 9. My brain's not working right now. It's going to be 63. Let me rewrite that because I'm writing it way too close together. 49x squared minus 63x. And then our last term is going to be the second one squared. So plus 81. Okay, so there are the factors listed out for that one. Okay, so this one ended up not having a greatest common factor, right? So if you think that there isn't one, then you can go ahead and find the factors. But remember, we always want to check for that first before we move on to factor it. Okay, so after you've finished these notes and everything, make sure to go back to Schoology and you have a exit ticket on there. It's a Google slide, so go ahead and complete that, and I will see y'all tomorrow.